Good day to everyone. Welcome back to my channel, Matheniks and more. Today, I'm going to discuss discriminant of the quadratic equation. We will characterize the roots of a quadratic equation using the discriminant, and we will describe the relationship between the coefficients and the roots of a quadratic equation. But before I proceed, if you think this video will help you to understand mathematics, please do subscribe, like and share, and hit the notification bell. Discriminant of the quadratic equation. In the quadratic formula, the expression underneath the square root sign is called the discriminant of the quadratic equations. Let's say we have the quadratic equation x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. According to the meaning of discriminant of the quadratic equation, the expression underneath the square root sign is called the discriminant of the quadratic equation. Looking to the quadratic equation, b squared minus 4ac is the expression underneath the square root sign, and therefore this is the discriminant of the quadratic equation. Normally represent capital D or delta, and it is equal to b squared minus 4ac. A quadratic equation with real coefficients can have either number one or two distinct real roots, and number two distinct complex roots. Three cases of discriminant. Number one is if the discriminant is positive, then there are two distinct roots. X sub 1 is equal to negative b plus square root of b squared minus 4ac all over 2a. Since the discriminant of quadratic equation represent delta or d, therefore x sub 1 is equal to negative b plus square root of delta over 2a, and x sub 2 is equal to negative b minus square root of b squared minus 4ac all over 2a. And again, the discriminant of quadratic equation represent delta. X sub 2 is equal to negative b minus square root of delta over 2a. Now, rewriting x sub 1 is equal to negative b plus square root of delta all over 2a, and also x sub 2 is equal to negative b minus square root of delta all over 2a, both of which are real numbers. And what are the real numbers? A real numbers is either rational numbers or irrational numbers. Rational numbers is negative 4, negative 1, 2, or 5. These are the example of rational numbers. What about irrational numbers? Example of irrational numbers are negative 1.2, square root of 2, 5 or cube root of 5. If the discriminant is 0, then there is exactly one real root. X is equal to negative b over 2a. And if the discriminant is negative, then there are no real roots. Instead, there are two distinct non-real complex roots. And x sub 1 is equal to negative b over 2a plus imaginary number I multiplied by square root of negative delta divided by 2a. And x sub 2 is equal to negative b over 2a minus I, the imaginary number, multiplied by square root of negative delta over 2a. I in the two equations is imaginary unit. Therefore, the roots are distinct if and only if the discriminant is non-zero, and the roots are real if and only if the discriminant is non-negative. Example number 1. 6x squared minus 30x plus 36 is equal to 0. Let us take all the coefficients a, b, and c. A is equal to 6, b is equal to negative 30, c is equal to 36. A here is quadratic coefficient, b is negative 30, and that is linear coefficient, and c as equal to 36 is constant. Solving for the discriminant, d is equal to delta or equal to b squared minus 4ac. Substitute the values of a, b, c. It is equal to negative 30 squared minus 4 multiplied by 6 multiplied by 36. And it is equal to 36. The discriminant is positive. Therefore, we have two distinct roots. Solving for x sub 1, it is equal to negative b plus square root of delta over 2a. Substitute the values of b and delta and a. It is equal to 30 plus square root of 36 over 2 multiplied by 6, or simply equal to positive 3. Solving for x sub 2, it is equal to negative b minus square root of delta over 2a. Substitute the values, it is equal to 30 minus square root of 36 divided by 2 multiplied by 6, and simply it is equal to positive 2. And then we have example number 2. 12x squared minus 24x plus 12 is equal to 0. Again, take the values of quadratic coefficient a is equal to 12. Take the values of linear coefficient b is equal to negative 24. And take the values of constant c is equal to 12. Again, solve for the value of discriminant equal to delta and equal to b squared minus 4ac. Substitute the values of a, b, and c to the equation. is equal to negative 24 quantity square minus 4 multiplied by 12 multiplied by 12, and simply it is equal to 0. Therefore, the discriminant is 0, only one exact real root. Our root x is equal to negative b over 2a. Substitute the values of b and a. It is, in this case, negative b multiplied by negative 24. It is simply equal to positive 24 divided by 2 multiplied by 12. And simply it is equal to positive 1. And that is our one real root. We have now exercise number 3, or example number 3. 10x squared minus 24x plus 15 is equal to 0. Again, take the values of quadratic coefficient 10, take the linear coefficient b, negative 24, and take the value of constant equal to 15. Solve for the value of discriminant equal to delta equal to b squared minus 4ac. Again, substitute the values of a, b, c to the equation. We have quantity negative 24 squared minus 4 multiplied by 10 multiplied by 15. And it is simply equal to negative 24. The discriminant is negative, then there are no real roots, but there are two distinct non-real complex roots. And to solve for these non-real complex roots, we have x sub 1 is equal to negative b over 2a plus imaginary number I multiplied by square root of negative delta over 2a. Substitute the values equal to 24 over 10 plus I imaginary number square root of negative 24 over 2 multiplied by 10. In this case, the value of 24 become positive because our linear coefficient is negative 24 and the formula is negative b. It will become positive 24. Computing x sub 2, we have negative b over 2a minus imaginary number multiplied by square root of negative delta divided by 2a, and it is equal to 24 over 2 multiplied by 10 minus imaginary number I multiplied by square root of negative 24 over 2 multiplied by 10. We have to simplify this further, and that is our two distinct non-real complex roots. Thank you. Thank you very much. And if you think this video is very helpful, please don't forget to subscribe, like and share, and hit the notification bell. And thank you very much. See you later.